In addition to polynomial equations, another type of very common equation that we look at in algebra is that of rational equations. And rational equations are just simply equations that deal with rational expressions. Okay, and that just means you have like a polynomial in the numerator and a polynomial in the denominator. Alright, so here I have some examples. I'm going to solve these rational equations. For part A, I have 2x cubed plus 4x squared over x squared minus 4x minus 12. That's on one side of the equation. On the other side of the equation, we have negative 7x minus 6 over x minus 6. Alright, so there's a lot going on here. And so I'm going to show you how to work these out. That's not too bad. The first thing though you want to do is you want to factor your denominators. Okay, so I'm going to go ahead and factor my denominator here, but I'm also going to factor my numerator for my first term, because I notice that I can take out a 2x squared out of everything, and I'm left with an x plus 2 when I do that. Okay, now my denominator, I have a quadratic, and I think it'll factor. I need two things to multiply to give me negative 12, add to give me negative 4. How about x minus 6 and x plus 2? Alright, now on the other side of the equation, I'm going to leave the numerator alone. And actually the denominator is already factored as well. Okay, so now from here, what I can see is there's some things that at the end of the day, x cannot be for sure. Okay, so from here I can see, I know for sure, x cannot be 6 and negative 2. And from over here, I got x can't be 6, okay, which we already stated. The reason is because if it's 6 or negative 2, I'm going to have a 0 in the denominator, and that's a problem. Alright, so that's a domain problem. Okay, so now what I also notice is the x plus 2 can cancel out on the numerator and the denominator. So I end up with 2x squared over x minus 6 equals negative 7x minus 6 over x minus 6. Okay, so now to clean this up, we want to get rid of those denominators. So what I do is I multiply both sides of my equation by the denominators. In this example, I'm left with the same denominator on both sides. So all I have to do is multiply in x minus 6 on both sides. And when I do that, I'm going to cancel out the x minus 6 out of both sides. Okay, so then I end up with 2x squared equals negative 7x minus 6, or 2x squared plus 7x plus 6 equals 0. This is a quadratic equation, right? So we can solve these in a variety of ways. I think this one will factor for us as 2x plus 1 and x plus 3. So here then I end up with x equals negative 1/2 from the first equation and negative 3 from the second. Okay, now since those do not fall into this list, I don't have to cancel anything out. And there are my solutions, negative 1/2 and negative 3. Alright, now let me show you another one. So for B part, I have 1 over t minus 3 plus 1 over t plus 2 equals t over t minus 3. Everything's factored. I do want to make a note here, though, that t cannot be positive 3 and negative 2. That's something we're going to need to keep up with at the end of this. And I'm going to multiply some stuff in to cancel all my denominators. And what can do that? Well, definitely if I multiply t minus 3, that will cancel that denominator. And if I multiply t minus 3 on this side as well, that is going to cancel out this denominator, but not the t plus 2. So I need to multiply in a t plus 2 as well. And if I do it to one side, I need to do it to both. Alright, so now when I multiply in this t plus 2 times t minus 3 across here, what happens? Well, my first term, the t minus 3's cancel out, and I'm left with just t plus 2. In my second term, when I multiply t plus 2, t minus 3 times 1 over t plus 2, the t plus 2's cancel out, and I'm left with a t minus 3. Now on the right hand side of the equation, the t minus 3's cancel out, and so I'm left with a t in the numerator times t plus 2. Alright, so now from here, I think I can solve this. Let's see, we get 2t minus 1 equals t squared plus 2t. Okay, so then I can make this a quadratic equation, bring everything over to the right hand side. I get 2t plus 2t minus 2t, so those go away, plus 1. Okay, so I end up with 0 equals t squared plus 1. If you want to solve this through the square root property, notice I have t squared equals negative 1. So when I take the square root of both sides, I have to have the square root of negative 1. If you remember, the square root of negative 1 is I. So I end up with plus or minus I. Okay, now if you didn't want to use the square root property, t squared plus 1 actually factors as t plus I times t minus I. Okay, if you didn't notice that, that's okay. You can always use the square root property. We end up with t equals plus or minus I. Since neither one of those are 3 or negative 2, we're good. This is what we have. All right, let me show you one more example. Okay, so from part C here we have 3 over x minus 1 minus 3 over x plus 2 equals 9 over x squared plus x minus 2. Okay, so the first thing I want to do is to factor the denominator on the right hand side. If I can think of two things to multiply, give me negative 2 and add to give me positive 1. How about positive 2 and negative 1? Okay, so I'm going to replace that quadratic with that expression. Alright, so now what I need to multiply on both sides of my equation, I have to get rid of all this stuff in the denominator. I'm going to multiply by x plus 2 times x minus 1 on the right. That will cancel out the denominator on the right. That means on the left hand side, I have to multiply in that same thing, x plus 2 times x minus 1. And notice that when I distribute this expression across these two terms, it will cancel out the denominators in each of those, right? So in the first one, I have a 3. The x minus 1's cancel, so I'm left with an x plus 2 in the numerator. In the second one, I have minus 3. This time the x plus 2's cancel out. I'm left with an x minus 1. And on the other side of my equation, I just have 9, right? Because everything else canceled out here. Okay, so this is actually a linear equation. 3x plus 6 minus 3x plus 3 equals 9. And something funny is happening here. Notice here that the 3x and the negative 3x are going to cancel out, so I end up with 9 equals 9. Okay, so now I need to ask myself, when does 9 equal 9? And so 9 always equals 9, meaning that my solution could be anything. Anything from negative infinity to infinity, right? So that's covering the entire number line like this. Well, that's not exactly true. There was one thing we forgot to do at the very beginning. I have an x minus 1, an x plus 2, an x plus 2, and x minus 1. This tells me x cannot be negative 2 or 1. Okay, so here's negative 2, I can't have that. And here's 1, I can't have that. So actually, negative infinity, positive infinity is not the correct answer. Okay, I can have anything from negative infinity up to negative 2. And I can also have anything from negative 2 to 1. And I can also have anything from 1 up to infinity. I just can't have negative 2 and 1 themselves. So that's why we need to make sure we pay attention to the denominators. Solving rational equations is actually easier than simplifying rational expressions because I can multiply both sides of the equation to get rid of the denominators. I hope this makes sense. If you have any questions on any of this, please let me know. I'd be glad to help. And thank you for watching.